So, hello, welcome to this talk about IPv6 address assignment considerations. Who of you is using IPv6 right now? Okay, a couple of you. Who of you is working for an access provider where end customers or business customers can dial in? Nobody. Any hosting providers here? Okay. Who is planning to use IPv6 in the near future? So you have 574 days left till the last /8 is given away by IANA, and then maybe about a year till the local registry run out of IPv4 space. So, first, this talk is not on how to split your /32, /48, /56, whatever you get from your provider. There are plenty of other talks and plenty of mails and guides on how to use your address space for your needs. This is more on how to assign an address. There are different methods of assigning addresses to an IPv6 interface. That is static configuration, stateless auto configuration, and DHCP. And some of them work pretty well, and some of them have some problems. And even the ones who work very well in one environment will make heavy problems in another environment. So, static configuration, very basic. You need them for router interfaces. There is no auto configuration on router interfaces. And I would recommend that for servers, videos, printers, and other stuff as well. You don't want your important services to change address after you switch the hardware and restore the backup. There is DNS, but you still have to think to change the DNS record when you do the service, and you have an Apache listening to this specific address, and if you change the hardware, you still have to change the Apache configuration and so on. So use static configuration for servers. Easily done. Everybody should know that iOS or my Linux box at home, little more typing here. They have to give a net mask and the default gateway. I missed the root up in the iOS example. Then there is stateless auto configuration. With stateless auto configuration, the client selects an interface identifier, which is with Ethernet the MAC address. This is slightly modified. There is MAC address is split in half, and an EF is inserted into the middle to have a 64-byte address. From this, a link local address is generated. Then there is duplicate address detection. I come to this in a bit. To check if this address is unique. Who is working in the networking environment for more than 10 years? There was 3Com. They introduced networking cards, and MAC addresses should be unique. Well, they wanted to save some money, and they used one batch of addresses for Europe, the same for Asia, and the same for the US. And they thought, this will never mix. We had about 10 network cards with identical MAC addresses. It was a very, very big pain in the ass to find those cards, especially if you don't have any managed equipment. Duplicate address detection tries to avoid this problem. With duplicate address detection, you will only have one MAC address in your network. It doesn't ensure that you have the right MAC address. After duplicate address detection is done, the router asks for prefixes via multicast, and if there is an IPv6 enabled router in the network, it will probably provide a prefix, and during runtime, the interface listens on the network for more prefixes, or if a prefix goes down, and we'll change that. Slack stateless auto configuration is great for client-only networks. Plug it in, you have an IP address, or guest networks, e.g. like this conference. Great, works absolutely fine. Duplicate address detection. You send out, the client sent out an ICMP message, type 135 to colon, which is an unspecified address. And if the address is already in use, there will be an answer to FF02 : 1, which is the multicast address. And your client won't take this address. Will take no address unless statically configured. There are some problems with Slack. There's no automatic entry into DNS, so your client doesn't enter his name into the DNS. There is no, oops, there's a typo. The 9 is wrong. There is RFC 5007 describes a way to assign a DNS server to an automatically configured device, but this is not supported by all devices and all routers. So that's a problem. So with older operating systems, you don't have a way to assign a name server to a device via router advertisements. Another problem is that everybody gets an IPv6 address, and really everybody. Those duplicate address detection can be faked. Is this address taken? Yes. Is this address taken? Yes. And you have a really nice denial of service attack to your network. So no client will get an address. So why is it a bad idea that everybody gets an address, an IPv6 address? So I've been working with a large hosting company in Germany, and they introduced IPv6 a couple of weeks ago. They are still in the beta phase. And the reason I am doing this talk is somebody wrote in his blog, yeah, I have to configure it manually, and it's too much work. Why can't they turn on auto configuration? Well, as I stated earlier, everyone gets an address. And consider this large hosting company. They have many, many different servers rented to different customers. So this means many, many administrators. Most of these administrators don't know really what they are doing. They have read somewhere, oh, Linux is great, and I really need my own web server to host my family web page with 10 pictures. And they might have a packet filter firewall for IPv4. They may even have configured some of their services to only listen to an IPv4 address, but that's maybe. And they most probably will have a default Linux setup with IPv6 enabled. So I have a packet filter for IPv4. You don't have configured your services correctly, and you have IPv6 enabled. What will happen if the provider turns on auto configuration? Yeah, the client will get an IPv6 address. Servers will start to listen on IPv6, and congratulations, you created a nice backdoor into your customer's host. And you can't do this in a hosting environment. Then this blog suggested to put all those clients who want to do IPv6 in a separate VLAN, but that means that you have to change on the routing on the IPv4 side, which is also a bad idea. With such environments, the administrators say, normally you say, we have a firewall, internet is evil, and here is our network, which is good. In these environments, it's evil, and the small part, which is your network, is good. So the enemy sits on both sides, as well as in the internet as in the internal network. So auto-configuration or doing anything automatically might be a bad idea. So far, any questions? There are some, can you read this? If not, oops, sorry. Let me go to router. Oops. Just checking if you're awake. So this should be a little bit better to read. So there are different ways to influence on how the router behaves on auto-configuration. You can influence, the prefix is the most important part, so give this prefix out to any client who connects. You can control the router advertisement. Should be router advertisement sent out to this network or not? And you can do some configs. DHCP, which is coming up next. You can influence the client via router config to use DHCP settings or not. This is also possible with, let's say, a Linux box with RRDVD, router advertising daemon, but that is not very well documented. That's why I'm using Cisco for this example here. So DHCP version 6 is quite like DHCP for IP version 4. We are using different ports. 546 for the client and 547 for a server and a relay. If you have some older Cisco equipment or some older iOS versions and want to use IPv6 and DHCP, as you might have a problem. So up to half a year ago, they didn't support IPv6 relay on the Catalyst 6500. That changed with an update, but you have to update all those features. And if you're reading the Cisco datasheet, IPv6 DHCP relay, we can use that. Try it first before you change something. DHCP version 6 sends no routing information to the client. It can be used to only transfer additional informations like DNS servers, NTP servers, and so on to a client, which makes it very, very easy to make a redundant setup. So you all will know the problem with a redundant or more than one DHCP server on IPv4. So somebody plugs in his home wireless router because he needs an additional network port at his desk, and he has DHCP enabled on the box, and suddenly you have 2 DHCP servers on your network and have very, very funny problems if you don't have any security measures on your switches implemented against that. So with IPv6, you can say my DHCP server will not assign any addresses, but only additional information, and you can have as many as you want in the network. You don't have to track if an address is in use or not. There are several solutions for this in IPv4. ISC DHCP does allow redundant setups. I guess Windows does, and Cisco had a very nice solution. You could FTP the leases file to an FTP server, and the second router, which was playing DHCP server, would pull it from there, and so they would have a redundant setup. Yeah, there is, as far as I know, no default way to create such a MAC IPv6 address binding. So This Mac from my laptop will always get this IPv6 address. Such a static assignment is done by a cookie which is set on the client side. There are ways around it by hooking up a script into your DHCP, but I haven't tried that. Client configuration is fairly easy. So by default, name servers and domain search are requested. And you can give additional parameters what should be grabbed from the server as well. And yeah, you can include local scripts. And the server, I stripped the demo configuration from a brand new ISC DHCP server from the commands. It's like ISC DHCP on IPv4. There are, at least for Linux, or for Unix, several different implementations. I see Dibbler. Who of you knows Terry Pratchett? Yeah, there's a name server called Dibbler. And one from the White project. So, I'm missing one slide here. One thing you can do with DHCP is DHCP IPv6 prefix deployment. So there are some companies and some customers who don't want static networks. So on the companies on the provider side, it's we can charge extra for static addresses, and on the customer side, it might be privacy concerns. If I have a static address, everybody can track me through the net, so I want dynamically assigned addresses. Therefore, DHCP prefix deployment was introduced, which allows you to dynamically allocate or provide a customer router with an IPv6 prefix. One problem here, there are, at least as I know, very, very few implementations for that. Server side, ISC works well, I was told. On the client side, yeah, I don't know if Cisco supports it or Juniper. And I don't know if anybody else does. So if you have yourself built a router with Linux, it's okay, but yeah. I guess AVM, do you know the Fritzbox? It's a German company, they are quite well known there, and they have a pretty decent support for IPv6. Still beta, but they do. And D-Link, I guess, has some support for DHCP prefix deployment. So I'm way too fast, but I expected some questions. Any questions? No questions.
Jakieś pytania do pana?
Okay. Okay. So yeah, some general books to read. Yeah, if you understand German, you can buy this one. Forgot that slide here. And if you want to contact me, information is there. And if you have any questions about IPv6 or something like that, just ask me. I'm around till tomorrow afternoon. Yeah.
Thank you. Thank you very much. Następny wykład odbędzie się o godzinie 16:05. Także mamy troszkę czasu, mogą sobie państwo odpocząć. Dziękuję.